Okay, hello everyone in a new video. So in this one we are going to start by chapter 6, part 1 of chapter 6, which is the center of mass for grade 11 students. So let me write here as a title chapter 6, center of mass. And let me start directly by the first section, section number 1, center of mass. Of an object. So, and let me consider for this case a solid S. So the center of mass or in other words center of gravity is a point in which all the mass of the object exists at that point. So in this case, because this solid S represents a regular shape, then the center of mass will be simply the center of this geometrical shape, and here I'm only considering homogeneous body. Okay, so the solid S consists of the same material, say for example wood or plastic. Now the more interesting, so why do we discuss center of mass? This is important when discussing forces, because we know that forces can be classified as a force acting at a distance or a contact force. The forces that act at a distance, basically that are given by the weight, the electric and the magnetic force, has a point of application which is center of gravity. So, and as we shall see in the case of rotation, it's important to determine the center of gravity. But the more interesting case is the center of gravity of a system, or the center of mass of a system. And for this reason, let me consider the following. So whenever we mention that it is a system that consists of several objects, for this reason, let me consider two objects. Say, for example, this is the object A. So, okay. And another object given by B. So suppose that this is the solid A and this is the solid B. So now let me represent the center of gravity of each object, or the center of mass. So this will be the center of this square, which is given by G1. And as for this object is given by G2. Now the center of mass of a system consisting of several bodies is given by or determined by the barycenter formula, which is given by OG vector, is equal to summation of mi OGI divided by the summation of mi. Now let me introduce each quantity. So this is said to be the barycenter formula. Then what does each quantity represent? OG is the location of the center of mass of the system, and it is expressed in meters. OGI is the location of the center of mass of different bodies that are involved in the system, and it is also expressed in meters. Whereas mi is the mass of the different bodies involved in the system, and it is expressed in kilograms. And here let me make the following important note. So notice that the barycenter formula that I didn't discuss yet, it includes vector. It's a vector relation, so vectors must exist on the left and on the right. And in order to deal with vectors, we need to consider a reference system. Before we use the barycenter formula, we need to consider a reference XY plane. So now let me use this formula in order to determine the location of the center of gravity of the system that consisting of A and B. Let me sketch again the following system. So this is the object A. And this is the object B. And let me consider, so let me say first that this is A and this is B of center of gravity G1 and G2 respectively. So referring to this, okay, now let me say that we are interested. So this is an example. We are interested in determining the center of mass G of the system A and B. So, and both of them okay. And according to this note, okay, here for sure we need to make use of the barycenter formula, which is given by OG is equal to summation of mi OGI divided by summation of mi. Now suppose in this case the mass of A is given by 4 kilograms and the mass of the object B is given by 2 kilograms. so the mass is important in this case. So, or let me say that this is M1. Okay. Now, referring to this note, before we use the barycenter formula, we need to consider a reference xy plane. So let's do so. Let me consider that this is the x-axis, and this is the y-axis. Then this is the positive direction of the x-axis, and this is the positive direction of the y-axis. Whenever we are discussing the barycenter formula, we know that always in physics, axes must be labeled by physical quantities. So let's consider that the x-axis is labeled by meters as well as for the y-axis, and this is the original. Okay, so before we start using the barycenter formula, let me determine the coordinates of the points G1 and G2. So as for the point G1, now suppose each division corresponds to 1 meter. So G1 is given by 1, 2, 3, 4, so it's given by -4 meters. Why meters? Because we have specified previously that the x-axis is labeled by meters. And as for the y-axis, it's given by 1, 2, so plus 2 meters. Now as for the position G2, G2 is given by 1, 2, 3, plus 3 meters. And as for the y of G2 is given by 1, so plus 1 meters. Okay, and for sure this is plus. Now the coordinates of G1 are given by -4 meters and 2 meters. And as for G2, it's given by 3 meters and 1 meters. And let me erase the coordinates from here. And this is G1. So now the barycenter formula is given by OG, which is equal to summation of MI OGI divided by summation of MI. Now what does I represent? Here we are summing over the index I. I represents the number of objects, and here the objects are simply given by A and B, so it's given by M1 OG1 plus M2 OG2 divided by M1 plus M2. This symbol is given by the sum, so we are summing over different indices, so it's given by M1 OG1 vector plus M2 OG2 vector. Okay, so in this case, this is the object 1 and this is the object 2. So this mass actually represents the mass M1 and this mass represents the mass M2. Okay, now this is a vector equation. Let me write it again here. And okay, it is a vector relation or definition because vectors exist on the left and on the right, and we know that each vector consists of two components, the x component and the y component. And here let's do projection along the x-axis and along the y-axis. So as for the projection, so the first step is always to choose the xy system. The second step is to locate the coordinates of the center of gravities of the different bodies. Now let's perform projection on the x-axis. Then this formula, okay, OG vector can be written as OGX I plus OGY J. Then as for the projection on the x-axis, so we drop down the vectors and each vector quantity will carry the component x or y. Here since we are dealing with the x-axis, then this equation is reduced to OGX is equal to M1 OG1X plus M2 OG2x divided by M1 plus M2. As for the projection on the y-axis, this formula is reduced to OGY is equal to, so we drop down the vectors and each vector quantity will carry the label y. Now we will use the following two formulas to determine the coordinates of the point G. What does G represent? It's the center of gravity of the system, which system consisting of the bodies A and B. So let me make some space here. Now as for the x component, this formula is given by OGX is equal to M1 OG1x plus M2 OG2x divided by M1 plus M2. This can be written also as M1. What does OG1x represent? It's simply the x coordinate of G1. So which is given, say for example, by x1 plus m2 x2 divided by m1 plus m2. Now this is x1 y1, this is x2 y2. Now the value of m1 is given by 4, the value of x1 is given by minus 4, the value of m2 is given by 2, and the value of x2 is given by 3, divided by the total mass, which is given by m1 plus m2, which is given by 4 plus 2. Plugging this fraction on the calculator, then it's given by minus 1.25. Because OG represents position, then the unit of OGX is given by meters. Then OGX is equal to minus 1.25 meters. Now as for OGY, it's given by M1 OG1Y plus M2 OG2Y divided by M1 plus M2, which is equal to this, in this case, M1Y1 plus M2Y2 divided by M1 plus M2. The value of M1 is given by 4, and the value of Y1 is given by 2. The value of M2 is given by 2. The value of Y2 is given by 1, divided by 4 plus 2. Plugging this fraction on the calculator, then the value of OGY is given by 1.67 almost meters. Then OGY is equal to 1.67 meters. Then the coordinates of the center of gravity of the system are given by the point G, which is given by minus 1.25 meters along with 1.67 meters. And in the vector notation, this is also given by OG vector is equal to minus 1.25 the unit vector I plus 1.67 the unit vector G. So what does this mean? Referring to this, let's locate the point G. So it's located minus 1.25, so this is the x, and as for the y, it's given by 1.67. So this is the point G. So both bodies A and B can be simply replaced by a simple body, which is the point G, given by its coordinate, which is this. Okay, so now suppose that here, say for example, we have so this is the weight W1 acting on the body A, and this is the weight W2 acting on the body 2. Both forces W1 and W2 can be replaced by the vector W, which is given by W1 plus W2, which is simply acting on this center of gravity G. Okay, so both bodies A and B can be replaced by the center of gravity or the center of mass G. Okay, so this is the center of gravity of the system given by A and B. Here let me say that this is minus 1.25 and this is 1.67 meters. And here let me say the following note that I have used. That OGX is simply the coordinates of the point GX, which I'm representing by XY, because we know that any vector OG has a component which is given by XG minus XO and YG minus YO. Whenever we are considering the vector and the first point is given by the origin, so the coordinates are given by 0, so this is given by XG and YG. Okay, and I have represented these points by given by, in case of OG1 X, so this is X1, and say for example OG2Y, this is given by Y2, because simply we have started with the origin as a point of application. Okay, so as you can see that the formula is very straightforward. Let's also consider another example. So suppose in this example that we have a rod. So this is the rod AB of length 1 meters and of mass M1 is equal to 2 kilograms. The sphere of radius 10 centimeters, which is equal to 0.1 meters, and of mass M2 is equal to 2 kilograms. So here we are interested, suppose we are interested in determining the center of gravity G of the system consisting of the objects or the bodies A and B. So let's apply the barycenter formula. But according to the previous note, before we use the barycenter formula, we need to consider a reference system. Then let me consider the reference system. So suppose that this is the x-axis, and this is the y-axis. And this is the origin O. Then we are interested in applying the barycenter formula, which is given by OG is equal to summation of MI OGI divided by summation of MI. So in this case, what does I represent? I represent the number of objects. We have object, this is the first object, which is the rod, and the second object, which is given by the sphere. So we are simply summing over 1 and 2, so this is given by M1 OG1 plus M2 OG2 divided by M1 plus M2. Now let's locate the coordinates of each of the points G1 and G2. G1 represents the center of gravity of the rod AB. So notice that here, because we are considering the rod to be homogeneous, then its center of gravity will be the center of the rod. So if the length of the rod is given by 1 meters, then G1 measured with respect to the origin O is given by 0.5 meters. As for the y-axis, it doesn't have any ordinates, so it's 0. As for the point G2, so let's suppose G2 coincides with B, since AB is equal to 1 meter, so this is given by 1 meters. So Now, because we have specified the coordinates g1 and g2 corresponding for the center of gravities g1 and g2 for the rod and for the sphere, now applying this formula will be straightforward. The next step is to project along the x-axis and the y-axis. So projection along the x-axis. So how do we project along the x-axis? Simply we get rid of the vector, and each vector quantity will carry the label x. So OGX is equal to M1 OG1x plus M2 OG2x divided by M1 plus M2. And since here this is a vector having a point of application O, so we can simply get rid of O, and OGX is written as the coordinate x of the point G, which is equal to M1 x1 plus M2 x2 divided by M1 plus M2. So now the value of M1 is given by 2, the value of x1, so this is x1 y1 x2 y2, and the value of x1 is given by 0.5 plus M2, which is given by 2, multiplied by x2, which is given by 1, divided by the total mass, which is given by M1 plus M2, so it's 2 plus 2, so this is equal to 1 plus 2 divided by 4, which is equal to 0.75 meters. Let me check. Yes. So we have that xg is equal to 0.75 meters. Now let's do the projection along the y-axis. And then a projection along the y-axis. So how do we project along a certain axis? We get rid of the vectors, and simply each vector quantity will carry the label y. Notice that the mass is a scalar quantity, so it cannot be projected neither on x neither on y. It's very similar to the time. So remember that time is absolute, time is relative, time cannot be projected neither on x nor on y. So in this case, OGY is equal to M1 OG1y plus M2 OG2y divided by M1 plus M2. And here, because O represents the origin, then simply this can be given by y of the point G, which is equal to M1 OG1y, let's give it a name, which is y1 plus M2 y2 divided by M1 plus M2. So here the values of y1 and y2 are given by 0, so they are simply 0 plus 0 divided by, because 0 multiplied by M1 is 0, let me write it explicitly. So M1 multiplied by 0 plus M2 multiplied by 0 divided by M1 plus M2, so it's given by 0 divided by a number, which is 0. Okay, 0 divided by any number is 0. So in this case, yg is equal to 0. Then the coordinates of the point G, which represent the center of mass of this system, is given by 0.75 meters and 0. So in the vector notation, OG is given by 0.75 meters and 0. So here we are simply locating the center of gravity of the system. So if this is 1 meter, this is 0.5 meters, and this is 0.5 meters, then simply the point G will be located somewhere here, okay? So the mass of this system consisting of the rod and the sphere is concentrated at this point, which is given by G 0.75 meters and 0. Now, what's the importance of locating the center of gravity? Now, the weight acting on this system has a point of application, which is the point G. What does weight represent? In this case, the weight represents the total weight of this system. Okay? Now, also let's consider the following example. So, we are interested in determining the coordinates of G. representing the center of gravity of the following system. In order to do so, let's locate the center of, so always first we locate the center of gravity of each body, then we write down the barycenter for, okay, we choose a reference system. So let me write here the steps. Choose reference system. Step 2, locate GI. What does GI represent? The center of gravity of different system. Step 3, write the barycenter formula. Step 4, project. Okay. Now let me here add some given. Suppose that this is the object A and this is the object B. Suppose that the mass of A is equal, say for example, 2 kilograms, whereas the mass of B is equal to 3 kilograms. So G, and let me say that A is equal, say for example, 10 centimeters. Okay. Now let's choose the coordinate system. If this point is set to be the origin, so let's choose that this is the x-axis, like this, and this is the y-axis. So we know that in physics that axes are labeled by physical quantities. So in this case, x is labeled by meters and y is labeled by meters. Okay. Now let's locate the center of gravity of the solid A. So notice that this is a homogeneous object, so the center of gravity will be at the center. So this is G1, and in this case this is G2. Then what are, okay, so we have done with the step 1. Now as for step 2, we need to locate the coordinates of G1 and G2. Let's do it now. So G1 is given by, okay, so this is A, and if all of this is a 3A, then this is 2A, then A, so this is given by A with A, then it's given by 2A, so plus 2A. Now we will keep everything in terms of A, then in the final result we replace the value of A. As for Y, so if this is A, then the location of G1 is given by A divided by 2. So these are the coordinates of G1, the center of mass of the body A with respect to small a. As for G2, the center of mass of object B, then this is given by A over 2. As for the y ordinate, it's given by 2A, which is half for A. Now we are ready to apply the barycenter formula, which is given by OG is equal to summation of mi OGI divided by summation of mi. So here I, we are summing over the number of objects we have. We have 2 objects, so it's simply given by m1 OG1 plus m2 OG2 divided by m1 plus m2. Now let's do the projection along the x-axis. Then how do we project along the x-axis? Simply we get rid of the vectors, and each vector quantity will carry the label x. In this case, because we are measuring with respect to the origin, then this can be given by xg, which is equal to m1, say for example x1 plus m2, x2 divided by m1 plus m2. So this is x1, y1, x2, y2. The value of m1 is given by 2, which is the mass of the object A, so this is 1 and this is 2. So it's given by 2 multiplied by x1, which is 2A, plus m2, which is given by the mass b, 3, multiplied by the value of x2, which is a over 2, divided by m1 plus m2, which is given by 2 plus 3. Then taking a as a common factor, we have 4 plus 3 over 2 divided by 5 multiplied by a. Plugging this fraction on the calculator, then it's given by 11 over 4 a. Then xg is given by 11 over 4 a. Now notice that here I didn't label any unit because the unit is included inside of a. Whenever quantities are expressed in terms of another quantities, we don't include any unit. Now let's do the projection along the y-axis. Then because we are projecting along the y-axis, so we drop down the vectors, and this is simply given by OGY is equal to m1 OG1y plus m2 OG2y divided by m1 plus m2. And because we are measuring with respect to the origin, then this is simply given by y of g, which is equal to m1 y1 plus m2 y2 divided by m1 plus m2. So the value of m1, which is ma, is given by 2, the value of y1, which is given by a over 2, and m2 is given by 3, and the value of y2 is given by 2a, divided by 2 plus 3. Taking a as a common factor, we are left with the following fraction. So this goes out with this, so 1 plus 6 divided by 5 multiplied by a, so it's equal to 7 over 5 multiplied by a. Then yg is given by 7 over 5 multiplied by a. So in this case, if xg is equal to 11 over 4a and a is equal to 10 centimeters, which is equal to 0.1 meter, then 11 divided by 4 multiplied by 0.1 is equal to 0.27, 275 centimeters, and yg is equal to 7 over 5 multiplied by a, which is equal to 7 over 5 multiplied by 0.1, which is equal to 0.14, sorry, this is meters. Okay, so the point G will be located 0.14 meters, and in the vector notation OG can be written as 0.27, 275i, 0. Okay, plus 0.14 J. And in this case, using a certain scale, we can determine the point G in this system. So why it's important to locate the point G? Say for example, if you are interested in determining the point of application of the weight not of the object A and not of the object B, but for the whole system, then we can locate the point G, and the weight will have a point of application, which is the point G. Here I'm not representing the point G because for sure a certain scale must be chosen, simply because here I'm taking A is equal to 10 centimeters, and notice that A in this case consists of 2 divisions, so the scale is not being specified. Okay, so that's it for me in this video, guys. In the next part, we'll complete solving exercises on the barycenter formula.